Hi Year 5s and happy Monday. I hope you've had a nice weekend. It's really nice to see you for another week of maths. This week we're looking at 3D shapes, and today's lesson is all about identifying, describing and naming 3D shapes. So we're going to be looking at lots of 3D shape language. Let's start with the review tasks. So first, see how many of these 3D shapes you can remember and name from your previous school learning, and then have a little look at what the teachers are saying about the shapes and see what you think as well. Pause the video now. Okay, so hopefully you got on well with remembering the shape names. If you weren't sure about some of the shape names, don't worry, because we're going to go through them all as we go through this lesson, and we're going to go through the teacher's statements bit by bit as well. I want to start by just talking about 3D shapes for a moment and just reviewing something about them. So it says here, a polyhedron, plural for polyhedra, so one polyhedron or four polyhedra, they're three-dimensional shapes made of flat 2D polygon faces, which meet along straight edges and vertices. There's lots of language here, so we're going to get to know this language a lot better as we go through this lesson. Okay, this is the main thing I want you to focus on right now. They're three-dimensional, 3D, because they have length, width and height. So if we're looking at this shape here, it's a cube and it's made of square faces. Okay, if I look at the bottom here, this would be a square face, and a square has got a length and it's got a width. Okay, all 2D shapes have a length and a width, don't they? But the thing about 3D shapes is that they've got a height as well, or a depth. Okay, so if you imagine a building or a swimming pool, as well as, you know, the sort of top face of the building or the swimming pool, as well as that 2D surface, you can also go down or you could go up the stairs in the building. So depth or height. And I like to think about it as the one that goes up and down, because that's easier for me. Okay, now Mr. Griffith says, I know that one of these shapes has 6 faces. So if we're talking about faces, we're talking about the 2D sides of the shape. I thought it would be good to just stop sharing my screen at the moment and just show you some shapes. I've gone around my house and I've had a little look for some different shapes, so you might want to do the same. You might want to pause the video and go and see if you can find a cuboid or a cube. Maybe a box that you can look at, maybe even a cylinder. I've got a cylinder here, it's a sugar cube. I've got a sphere here, a tennis ball. I've even got another cylinder up here, a battery. Don't worry if there are bits sticking out, we're just looking at kind of the overall shape. Now to show you the faces, what I've done here is I've got my cuboid and I've put a post-it note over the top, because a face is the flat part of the shape. It's almost like we could peel it off. Okay, so I've put a post-it note here. Ooh. Hopefully this is going to work. Ooh. Just a bit fiddly. I've unfolded this already. Okay, so if I peel this face off, I've actually got a 2-dimensional square there. Okay, so if I put that back over the top, we can say that that face, that end face of the cuboid, is a square. Okay, and actually, ooh, sorry, I've got one on the other side as well. Okay, so I've got that flat part of the shape that I'm looking at now is a square. Peel it off, make a square. Now I know that the other faces are not squares, because if I use my square, they're actually bigger than the square, aren't they? They're longer, so they're rectangular faces. Okay, so imagine the face as the flat part of the shape that we could peel off. Now you might be thinking, but not all of the faces are flat, because we've got shapes like cylinders. So if I show you the end of my cylinder here, that's like a circle. I could peel that off and I'd have a 2D circle. But this is a curved face, which is tricky. But I just want to show you something cool. I've got a rectangular piece of paper here. And if I put my rectangle carefully over the curved face of my cylinder, you'll see that it covers it pretty much exactly. It's just a little bit left there because I didn't make it big enough. Okay, and if I actually uncurl that curved face, you can see that that face opens out to be a rectangle. So that's still a face, isn't it? Okay, a rectangular face, even though it doesn't look like it is. That's going to help us when we come to do our nets later, because we can see that we've got a circle and then another circle and actually a rectangle for our curved face. Hopefully that makes sense. Now, if you wanted to count the faces, you could do that with the actual physical shape in your hand. You could count them 1, 2, I always do opposite ends. And then you could maybe think about the ones going around the middle, like a belt, 3, 4, 5, 6. You could touch them with your finger, or you could use a pen to make a mark. So 1, 2, 3, 4, 5, 6, and then you can check that you've marked everything. It's a little bit trickier when you're looking at it on paper, so we're going to look at that next. It is possible though, so you want to use a pencil or something to do that. So let me just share my screen again. So Mr. Griffith says that he knows that one of these shapes has 6 faces. Well, the cuboid had 6 faces. I just checked them, didn't I? But what I'd want to do, if I'm looking at the actual representation of the cuboid here, is I'd want to decide which way I'm going to count them, and I'd want to just make a mark on each face to kind of tally them off. So if I count maybe all of the each end face first, that's 1, 2. I know that one's kind of see-through, but I'm looking at that end face, 1, 2. And then I've got 4 going around the middle, haven't I? I've got the top face, so that would be 3. I've got the back face, 4, bottom, 5, and front, 6. So hopefully you can see how I counted those. You have really got to think about the shape being in 3 dimensions, and think about if you could get behind it or look in front of it or look at either side. Okay, you'll get used to doing that today. Now the cube has also got 6 faces, because a cube is very similar to a cuboid. It's just got square faces instead of those rectangular faces. So again, I'll count the top and the bottom this time. So 1, 2, and then I'll count the ones around the edges. 3, there's the back, 4, 5, and then the front, 6. Now, if I look at the cylinder, we looked at the cylinder together, didn't we? We've got those 2 circular faces and then 1 rectangular face that curves round. So that's 3 faces for the cylinder. Now, the sphere is an interesting one. The sphere actually just has 1 curved face. Okay, there we go. So use that little tip of checking off the faces when you have to count them yourself. Mrs. Bracknell says these shapes all have more vertices than edges. So let's remind ourselves that vertices mean corners. We know that from our 2D shapes. Edges are either straight edges, but we can also have curved edges for non-polyhedral shapes. So if it's a polyhedron, then it's got a straight edge. If it's a non-polyhedron, it's got a curved edge. So just pause the video now. I want you to think about these questions. Which of these 3D shapes has the most vertices? Corners. Which of the 3D shapes has the least vertices? Corners. Pause the video now. Okay, so hopefully you were looking at some of the cubes and the cuboids for the most vertices. If I just show you how I would count the vertices, I'd look at maybe the top of the shape, decide to look at the top, and I'd count the corners where the edges meet. So there's 1, 2, 3, 4. Now I know I'm looking at these lines now and I could look at these edges, but I've already counted these vertices. So you just need to count the vertices once. Okay, so I've counted the top. I might now go to the bottom and do the same. 1, 2, 3, 4. So 4 and 4 makes 8 vertices. Okay, and I know that my cube has got the same. 1, 2, 3, 4, 5, 6, 7, 8. And it doesn't look like any other shapes have got more than that. This one I think has got a bit less. 1, 2, 3. And then opposite 4, 5, 6. So yeah, it's the cube and the cuboid with the most vertices. The one with the least vertices, well, we've got a few to choose from actually, because there are no vertices on the cylinder. It might look like there's vertices at each end, but remember that it was a circle, a curve, so no corners on the circle. So no vertices, and I've shown you the Pringle tube version of the cylinder there. So same shape, just in a practical sense, no vertices there. And the sphere has got no corners as well, because it's just one curved face. And also, we could look at the cone here, but that has got a vertice. It's got the apex at the top. Okay, so sphere or cylinder for that one. Now we can start to think about what Mrs. Bracknell was actually saying. She was saying these shapes all have more vertices, corners, than edges. So now we're going to need to think about our edges as well. And remember, they're straight or curved. So let's look at the cuboid first. Number of faces is 6. Number of vertices we know is 8 because we counted it before. Now I need to count the edges. So I would use my pencil and I would go along and trace over all of the edges and count at the same time. Let me just sort of demonstrate that. And again, choose where you're going to start. So if you're going to start at the top do all the top edges of the top face, and then maybe think strategically about how you're going to do it. So if I start to count 1, 2, 3, 4, I might go to the bottom and do the parallel, 5, 6, 7, 8. Now I've got the ones just joining at the sides. So I was on 8, 9, 10, 11, 12. I want to make sure that I don't count any edges twice. So there were 12 edges. Okay, now I know that the cube has actually got the same. Okay, they're the same. It's just the shape of the face that's different. Now let me look at the square-based pyramid. So I'll do the vertices first. Here's my square-based pyramid. So let me count the vertices of the square base first. 1, 2, 3, 4. And now I'll count the apex at the top. That's 5. And now I can count the edges by tracing with my pen. I'll do the square first. 1, 2, 3, 4. And then I'll do the connecting edges. 5, 6, 7. And then there's the one at the back. You can never forget the ones that you can't really see at the back. So that was 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh, put it in the wrong colour. So actually, I'm looking at what Mrs. Bracknell was saying, and it actually looks like there are more edges than vertices, doesn't it? Let's look at the cone. Let's look at how many edges and vertices the cone has. So we know that the cone has got no vertices. Let's look at the edges. So I can see that we've got a curved edge there and another curved edge there. That's 2 edges. You might think that these are edges, but remember that that was a curved face. Okay, so no edges there, even though we've got these joining lines. That's just to kind of mark out where the shape ends, isn't it? But they're not actually edges. And the sphere, let's look at the sphere. There are no vertices on the sphere. And actually there are no edges on the sphere because it's just got one curved face. So you could investigate that further and see if there is a shape that has more vertices than edges, but it looks from our investigations here that more shapes have more edges than vertices. Okay, what I want you to do now is pause the video and use what we've learnt about looking for faces, edges and vertices to complete the guided practice. Okay, off we go. Okay, so let's look at question A first. It says, say what is the same and what is different about the pictures that have been chosen. So hopefully you've seen that I've given you a representation that's see-through, so you can try and see all the different faces, even those ones at the back. But sometimes you'll be given pictures where the shapes are solid, and so you're going to have to imagine those faces at the back, imagine turning the shape. Sometimes you might see people drawing on dotted lines to kind of show where those back faces would be. That's a really good idea because then you're not going to miss anything. And you might have noticed that I've given you real objects. So remember that these 3D shapes are real objects too. So we can still find the edges, faces and vertices on those. So let's just go through quickly and fill these in. So we know that the top one is a cube. I'll try and write cube with my mouse. We know that it's got 6 faces. Okay, and this is what I mean. If we just look at this shape, the solid one, it looks like there are only 1, 2, 3 faces. But if we think about those dotted lines and separate it, then we can count the bottom face. That would be 4, then the back side and the back side there. So that would be 6, okay? Now, looking at this one, I wonder if I misled anybody here, okay? Because actually this is a Rubik's Cube made up of smaller cubes, but we're still looking at the overall cube shape. So here is a face. That's just one face, okay? Not 9 small faces. So one face, got 2 faces, 3, and then we'd have 4, 5, and 6. Okay, so still 6 faces, regardless of the cube representation. And so we know that we have got 12 edges as well from what we've learned before, and we know that we've got 8 vertices. Okay, and let's fill in this one really quickly because it's a cuboid. I'll just write cuboid. Oh, well, I'll try cuboid. There we go. It's hard to write with a mouse. We know that there are 6 faces. Doesn't matter what representation it is, there are 6 faces. We know that there are another 12 edges and another 8 vertices, as we proved it before. And then looking at this one, it's a cylinder. I'll just write cyl. Okay, we've got 3 faces. And again, it doesn't matter even if that shape is solid because I can see that face at the bottom as well as the top, and then the one that's curved. And it doesn't matter on the Pringles tube either, I could see that curved face at the back, okay? And so we can still see that there are 2 curved edges and there are no vertices. So hopefully you got the same as me. Now, I want us to move on to what I was saying. I was saying that these shapes are all prisms. I wonder if you agreed or disagreed. We might need to remind ourselves what actually is a prism. So here are some prisms. I want you to look at the prisms and pause the video and think about what's the same about all of the prisms and what is different about all of the prisms. And you might want to think about whether a cylinder is a prism as well. Okay, pause the video. Okay, so hopefully you have noticed a few things that are the same about prisms. One of the things that is the same is that the opposite end faces are exactly the same. So this is called a triangular prism because it's got triangles at either end. This is a square prism because it's got squares at either end and they are opposite. This is a rectangular prism because it's got rectangles. Hopefully you can see what I mean. And what's interesting, if I just play with this for a minute and make that a bit stronger, they are exactly the same. If I just show you, if I chopped this triangular prism, if it was a Toblerone bar or something and I chopped it and made it shorter, I would still have a triangular prism on this side, even if it wasn't quite at the end. If I made it shorter, it would still be exactly the same. So they are opposite. And that's actually because of the parallel lines of those rectangular faces at the side. Okay, this line is parallel to this line. They're the same distance away all the time. They don't get shorter, okay? So we end up with the same shape on each opposite end. If I show you with the pentagon as well, I'll just make it a bit stronger. If I drag my shape along, you can see that it is exactly the same. Doesn't matter where it is along the prism. And hopefully you've also noticed that every single prism has got rectangular faces on the side. We've got 3 rectangles here, 4 rectangles there because of the square. We've got 4 rectangles here and 5 rectangles here. And how many for the hexagon? It would be 6 rectangles because we've got a rectangle coming off of every edge of our hexagon face. So those are the 2 things. Notice the rectangles. Sometimes it might be parallelograms because parallelograms are also rectangles. Notice the opposite faces being the same, okay? Is a cylinder a prism? Well, this is an interesting one and it's thrown me before this question. It's got opposite faces that are the same, but it doesn't have straight side faces, okay? It doesn't have flat side faces like these other prisms. These have flat side faces because they have rectangular faces at the sides. But remember, this is a curve. Even though it opens out to make a rectangle, it's still a curve. So we would call this not a prism. It's actually a non-polyhedron, a bit like a non-polygon for a circle, okay? So in order for it to be a prism, it has to have straight, flat sides or faces. Hopefully that makes sense. Now let's look at pyramids. Okay, so again, pause the video, look at what's the same about all of the pyramids and what's different about the pyramids, and have a think about whether a cone is a pyramid or not. Okay, so hopefully you can see that what's the same about all the pyramids is that they all meet at a point at the top called an apex, okay? And that is opposite something called the base. The base is the flat shape that the pyramid would sit on. So if I just turn this, I'll sort of show you what I mean. I wouldn't be able to put the shape on a table and balance it on its apex, on that vertice, would I? It would just fall over. So the base face, that rhymes, I know. The base face is what it would sit on. And that is actually what names the shape. So if you're ever not sure about the name of a pyramid, look at the base shape. Okay, so if it's got a square base, it's a square base pyramid. If it's got a pentagon base, it's a pentagonal base pyramid. And I hope you can see here that the apex, the vertice at the top where all the other faces meet, is directly opposite the base face. Okay, now you might think that doesn't look like a square because it's got diagonal lines, but actually remember that because of perspective, which we're going to look at tomorrow, it's kind of a square that's been sat back. Okay, we're looking at this almost from the front and it's going back, so we show those diagonal lines to show the perspective, the 3 dimensions. If I just bring this shape down and put it on top of this square, you can see that actually it starts to look like it's making a cube, doesn't it? If I put in perhaps some other edges of my cube. Okay, so hopefully that shows you what I mean. It's still a square, even though it doesn't actually look like a square, which is quite strange. And the same for the others. If I bring the hexagon down, you can see that it is a hexagon. It's just a hexagon represented in 3 dimensions. Okay, hopefully that makes sense. Now, is a cone a pyramid? You can say that a cone is pyramid-like, but it's a bit like what we were talking about with the cylinder. We'd need to have flat faces. So if you had an infinite number of flat side faces, you would actually end up with a circle. So we can call a cone like a pyramid. It's a like pyramid shape. Hopefully that makes sense. Okay, what I want you to do now is pause the video and see if you can sort the shapes into the correct type using what you have now learned about prisms and pyramids and the ones that don't fit into either category. And then I want you to guess my shape. Pause the video. Okay, hopefully you got on well with that. So let's look for the prisms first. So we're looking at those opposite end faces that are the same and those rectangular faces in between. So I can see the cube, I can see the cuboid. There's my Jacob's crackers. That's another cuboid. I can see a triangular cuboid, triangular prism as well. I think that's it. Now let's look. The cylinders are the ones that are misleading. They have got faces that are the same at either end, but they don't have those rectangular flat faces. We've got the curved faces, so I'll put those in the neither column. Now let's look at the pyramids. So I can see a triangular base pyramid there meeting at an apex. The apex is opposite the base, and there is a square base pyramid. I'm going to put the cone in between, I think, because if it was an infinite number of flat sides, it would make a cone, but we don't know if that's what it is. Okay, so I'm going to put the sphere in neither because this one is neither a prism nor a pyramid. Guess my shape. This shape has no vertices and no edges. So no vertices, no edges. That means it could be any one of these, I think. But it has one curved face. Well, I know that the cylinder has got more than one curved face. It's got 2 circular faces, 1 curved face. So I think it has to be the sphere. No vertices, no edges, just 1 curved face. The 3D shape has the same number of faces as vertices, so I'm going to have to try some things out now. I remember that it can't be the cuboid or the cube because they had different numbers of faces and vertices. I could try this one, or I could try a pyramid. So let me just have a little play with this and you might want to do the same. Okay, so let me look for the faces and vertices. I know that the square base pyramid has got 1, 2, 3, 4, 5 faces. And it's got 1, 2, 3, 4, 5 vertices. So the square base pyramid could be one of the ones that fits that. Maybe we had a different one. Okay, now I want you to have a go at your independent practice. So you've got a task where you've got to fill in some information based on what you've learnt. I want you to name a difference between a pyramid and a prism. I want you to look at the different shapes and think about the odd one out. And then I want you to see if you can create some of your own odd one out style questions, or maybe some guess my shape statements like in guided practice 2. And then finally, I want you to see what 3D shapes you can see in the picture below. You might want to make a list or a tally to record which shapes there are and how many there are. And I'd also like you, as an extra task, to go around your house and see how many different 3D shapes you can see. Again, you might want to make a tally and think about which ones you see more often and why that might be. Finally, there's a deeper thinking challenge, and then there are the answers at the end, so don't skip ahead. It would be great to see what you come up with. Please send your work into Year 5 email as always. Bye, guys.